What do planets like to read? Comic books. What did the Earth say when the comet was coming towards it? Come at me, bro.
Basically, comet mining is where we take natural materials off the comet and bring them back to Earth, because Earth is running out of resources. We can do that by using ice rockets, but we'll get more into that later. Comet mining is theoretical, but quite possible.
Hey, hold up. So, why haven't we done anything about this yet?
That's a great question. Let's talk about it.
Come at me, bro!
So, you guys know how orbits work, right?
Yeah.
Yeah, no.
Okay, so there's this one guy, Isaac Newton. So, anyway, Isaac Newton was essentially the first guy to believe that gravity was a predictable force here on Earth, but he also found his first law of motion, aka inertia, where objects in motion stay in motion and objects at rest will stay at rest.
Yeah, so kind of like how when I throw a ball into space, it goes on and on forever. Kind of like how history class does when I'm hungry.
But, Karinne, you're always hungry.
Facts. Just like this video.
So things in space orbit because the straightforward motion of objects that would normally just continue on forever is stopped by the gravity of another object. So Earth orbits around the sun in a continuous pattern, but also in a spherical motion.
I'm a star, because one of these days I'm going to crash and burn.
Isaac Newton also believed and found his third law of motion, talking about how for each action there is an equal and opposite reaction. So when a rocket forcefully ejects matter out of the base of it, the equal and opposite force will push the rocket into the sky, which is exactly what we're looking for a rocket. And the acceleration of that rocket is dependent on the exhaust velocity of it, the rate at which the mass is ejected, and also the mass of the rocket. The more force that a rocket can eject, the farther that rocket will go. Kind of like going over to this whiteboard. So the equation for the acceleration of a rocket is determined right here. So acceleration equals the exhaust velocity divided by the mass of the rocket, multiplied by the mass of the fuel that was being exhausted, divided by the time, and then subtracting the acceleration due to gravity. So how this works is we want a rocket that's going to be light enough to get into the atmosphere while successfully having both astronauts and the tools necessary to mine a comet. But furthermore, that rocket also has to be light enough and sturdy enough to make it through our atmosphere. Over time, the rocket's weight will decrease as it uses all of its fuel, and parts of the rocket might actually break off as they become unnecessary for the rest of the flight. On Earth, we have a circular orbit around the sun. However, most comets have an elliptical orbit that goes almost like this. As in order to find the rocket trajectory, we have to calculate both the speed and the direction of the rocket to be able to make it go from the starting position at Earth when it leaves to the position where the comet will be at its arrival. So while the comet might be at one point in its trajectory, we have to calculate this direction to actually reach the comet. Astronauts need to have food, supplies, and things that they can actually mine the comet with. Because comets have 0 to no gravity, something like a canvas can be helpful to catch all of the materials.
Look at all those comets!
So, we all know that exercise on Earth is part of a healthy and productive lifestyle, but this is even more so in space. The amounts of immense G-force and weightlessness, no gravity, have many effects on the body. For example, muscle atrophy, skeletal deterioration, slowing of the cardiovascular system, decreased red blood cells, changes in immune system, and most importantly, changes in the aerobic fitness of one's being. 30% of muscle tissue is actually lost in spending 110 to 237 days in space. So how do astronauts minimize the effects of space in space? Exercise.
Did someone say exercise?
Researchers have found that the integration of aerobic and resistance exercises help astronauts maintain healthy muscle mass and bone strength. I talked earlier about some of the effects of space on a human in space, but the biggest one of them all is probably aerobic fitness. And aerobic fitness is measured by your aerobic capacity, the maximum amount of oxygen that the body can use during an exercise. This can be measured by a VO2 max and a VO2 peak test. Changes to both muscles and cardiovascular system caused by spaceflight contributed to the reduced aerobic fitness. After 9 to 14 days, for example, research shows that the VO2 peak test is reduced by nearly 20 to 25%, but the trends are interesting. During longer times in space, the body begins to compensate for this and the numbers actually begin to improve. Comet mining mission, the astronaut will be doing physical work when mining. A prolonged journey to space will hopefully help ease the side effects of space on the astronaut. For example, take a teacher at a school. They're going to sit at a desk longer than they're going to be up and active. So they're going to have to exercise more than someone who's, say, a PE teacher who's moving around all the time. Someone in the International Space Station will probably need to exercise more than a comet miner because just of what their work is, they're going to be moving around more often. But NASA has found that optimizing exercise and the integration of aerobic exercises, these lead to an optimized life for the miner in space.
Wonder how these astronauts can get home.
An ice rocket is really what the name says it is. A rocket that runs off of ice to be able to get out of the Earth's gravity and return from the comet. The engine slowly eats the ice, converting it into a high-velocity vapor exhaust. Now, I'm sure you're asking, how does one make an ice rocket?
I mean, couldn't we just make a sculpture in the shape of a rocket out of ice?
I mean, you could, but not in this sense. How to make an ice rocket. First, you melt cometary ice and purify it with centrifuge. You make an ice cylinder in 2 steps. Freeze a thin shell by wetting a large and cold cylinder form. As the ice gets thicker, freezes more slowly, so then you can start adding scores of small spheres across the shaded vacuum. They will freeze on the outside while continuing to freeze as the rocket travels on.
Freezing like time during the school year?
Alright guys, it's time to talk about the hard stuff.
Isn't my life hard enough as it is?
Oh, Karinne. Anyways, let's get this out of the way. So Karinne was talking about ice rockets, and today I'm going to talk about how we can fuel them. We can fuel them using extraterrestrial electrolysis. Now, extraterrestrial electrolysis is one possible source of fuel that we can use to fuel these ice rockets that is very combustible at very low cost.
Did you get this technology from Area 51?
No, Tanner, what the hell are you talking about?
No, definitely not.
Not me. In any case, to start this process, we are going to extract hydrogen and oxygen from a source such as water or a hydrocarbon. We can extract this from a comet or from the Earth itself. After this, we are going to use an electrical current to separate the hydrogen and the oxygen from each other. The hydrogen then goes into a canister where it is pressurized and uses fuel to propel the rocket.
Chemistry.
Physics.
Sports, exercise, and health science.